Another major new feature of our custom RDNA 2-based GPU is ray tracing, using the same strategy as AMD's upcoming PC GPUs. The CUs contain a new specialized unit called the intersection engine, which can calculate the intersection of rays with boxes and triangles. To use the intersection engine, first you build what is called an acceleration structure. It's data in RAM that contains all of your geometry. There's a specific set of formats you can use. They're variations on the same BVH concept. Then, in your shader program, you use a new instruction that asks the intersection engine to check a ray against the BVH. While the intersection engine is processing the requested ray triangle or ray box intersections, the shaders are free to do other work. Having said that, the ray tracing instruction is pretty memory intensive, so it's a good mix with logic-heavy code. There's of course no need to use ray tracing. PS4 graphics engines will run just fine on PlayStation 5. But it presents an opportunity for those interested. I'm thinking it'll take less than 1 million rays a second to have a big impact on audio. That should be enough for audio occlusion and some reverb calculations. With a bit more of the GPU invested in ray tracing, it should be possible to do some very nice global illumination. Having said that, adding ray-traced shadows and reflections to a traditional graphics engine could easily take hundreds of millions of rays a second, and full ray tracing could take billions. How far can we go? I'm starting to get quite bullish. I've already seen a PlayStation 5 title that's successfully using ray tracing-based reflections in complex animated scenes with only modest costs. Another set of issues for the GPU involved size and frequency. How big do we make the GPU, and what frequency do we run it at? This is a balancing act. The chip has a cost, and there's a cost for whatever we use to supply that chip with power and to cool it. In general, I like running the GPU at higher frequency. Let me show you why.